All right, let's take a look at the next part of these notes. It says, now we need to find the vertical asymptotes and any holes in the graph. We usually find vertical asymptotes and holes in the graph by first finding the zeros of the denominator. We do this by factoring the numerator and denominator. A number that makes the denominator equal to 0 is not in the domain. If the factor that produced the 0 divides out, there's a hole in the graph and that x value, at that x value. If the 0 doesn't divide out, then there's a vertical asymptote at that x value. So I want to figure out the vertical asymptotes and or holes for each of these. So I'm going to figure out if the zeros will divide out or if the zeros will not divide out. That's kind of what I'm looking at. The zeros in the denominator. All right, so it looks like I've got an x minus 1 in this first denominator. And x minus 1, it does not divide out at all with the x plus 3. So I'm in the does not divide out category. Maybe I'll try to color coordinate this. The 0 doesn't divide out. That would be this one. Which means that there's a vertical asymptote at this x value. A vertical asymptote, a vertical line of any kind, it will be x equals some number. And what makes my denominator equal to 0 is a positive 1. So x equals positive 1 is a vertical asymptote. All right. And then to state the domain, I'm thinking of this graph. I've got a vertical asymptote at 1, but I should have part of my graph on the left and on the right of that vertical asymptote. So for that reason, my domain is going to be everything except for the x value of 1. Or in other words, I can say from -infinity up to 1 union with everything after 1, so 1 to positive infinity. All right, so there's the vertical asymptote and the domain. So for part B, I'm going to try to figure out if the zeros in the denominator, if they divide out or not. So I'm going to have to factor this denominator into an x plus 2 times x minus 2. And it looks like the x plus 2 does not divide out with a plain x. X minus 2 does not divide out with a plain x. So for that reason, I'm in the vertical asymptote section again. They did not divide out. So I'm going to have each of these set equal to 0. And it looks like x equals -2 and x equals +2. Those are both going to be vertical asymptotes. I've got 2 separate vertical asymptotes. Put a comma there. There's my 2 separate vertical asymptotes. Now for the domain, again, I'm kind of visualizing this on a graph. At -2, I've got this vertical asymptote. At +2, I've got this vertical asymptote. And I should be able to hit everything except for those asymptotes, which means if I break it up into intervals, I've got like 3 different intervals. So my domain, I can either say that x does not equal these 2 numbers, -2 or +2. I could also say it's the intervals. Get rid of this. Say it's the intervals from -infinity up to the -2, and there, and then that middle section from -2 to +2. Union and combine that last section from 2 to infinity. Okay, so whether you want inequality or intervals, those both are talking about the same thing. All right, and then part C here, I'm going to factor the denominator again. So I get x minus 1, and this is the difference of squares. So I get an x plus 1 times x minus 1, which in this case, these do divide out. I've got an x minus 1 over another x minus 1. So those factors divide out. My final simplified version is 1 over x plus 1, but because I divided out the x minus 1s, that's going to be in this zeros divide out. It is a hole in the graph. not just a vertical asymptote, it's a hole in the graph. All right, which means that that hole has to be at the x value of +1. That's what makes that factor equal to 0, +1. Okay, so this is going to be a hole in the graph. The part that did not divide out, the x plus 1 in the denominator, that is going to give me x equals -1 as a vertical asymptote because it did not divide out. This one is a vertical asymptote. Okay, so as far as the domain goes, on my graph, I've got a vertical asymptote at -1, and then at +1, there's a hole in the graph. I didn't figure out exactly where it is. Maybe there's a hole up here. Maybe there's a hole down here, whatever. There's a hole in the graph though, meaning that it'll look like a continuous function. It looks like it goes on forever, but then it skips that one x value. So that's why there will be a hole in the graph. And again, I didn't specify exactly where it is. I just know that it's at the x value of +1. So my domain is going to have to be, this left section here is everything from -infinity up to -1. And then I have this middle section here, like, again, if it was curving like this, again, I'm not sure what the graph looks like, but if it's doing something like this, the x values here between the -1 and +1, those do exist. So I would say from -1 to +1, union, I had to skip that single point, and it'll be everything after that. So that would be from +1 to infinity. Okay, as far as an inequality goes, or sorry, not an inequality, as far as excluding x values, I can say x does not equal the -1 or the +1. So pay attention to how your homework wants you to enter the answer. All right, and then part D, I'm going to attempt to factor again and then divide stuff out. So let's see, if I want to factor the numerator, let's see, what multiplies to be -3 and adds up to a 1. And in this case, the only things that multiply to be a -3 are either a -1 times 3 or -3 times +1. And I'm talking rationals here, like fraction form. That's all I've got that multiplies to be -3 and adds up to 1. And any of these don't include a 2. So, I mean, I can't really factor anything out that matches the x plus 2. So for that reason, I know that it's not going to divide out, which means that this would be a vertical asymptote at x equals -2. All right, and I only care about setting the denominator equal to 0. I don't mind what makes the numerator equal to 0, so I'm not going to worry about that. On my graph at x value of -2, I've got a vertical asymptote there, which means the domain should be everything to the left and everything to the right of the -2, just not the -2 itself. So the domain in this case, you can either say x does not, or x equals, let's see, x does not equal the -2. It's everything except for the -2. Or you can say it's the interval from -infinity up to -2, and then parentheses here again means I'm skipping the -2, and I go -2 up to +infinity. So it's pretty much saying everything except for -2. All right, so there are the vertical asymptotes and the hole.